Hello. This is another project in 21 and 21 projects in 21 days. This one is the second part of the Azure series, Azure with AI. So in the last one, we built a streaming backend on Azure, hosted on Azure, with serverless functions, so that and we set up a database in the secret mission. If you haven't, we did that here as well, just to catch up. But yeah, it's sort of infrastructure so that we can pull in messages and then send messages as well. Sort of simulate that whole thing with different APIs. So in this one, we're going to be creating a production grade content moderation API that filters toxic messages in milliseconds. So build the same AI-powered system used by platforms that process millions of messages daily. So it's reasonably difficult, about 60 minutes. There's two parts. There's two more parts coming of this series shortly. And then, we go into Gemini API, Azure Functions, Cosmos DB, and content moderation. Cool, so a 30-second summary. Every platform with user chat faces the same challenge. Toxic messages, spam, and abuse can destroy a community in seconds. Twitch processes over 30 million messages daily. YouTube comments hit billions. Manual moderation simply can't keep up. That's why platforms like Twitch, YouTube, and Discord use AI to screen content real time. Companies like Match Group, such as Tinder and Hinge, and Midjourney, it's like an online Discord server that uses, it's a company that uses a Discord server, hosts on a Discord server. It's the biggest Discord server in the world, if I'm not mistaken, to filter millions of interactions before harmful content ever reaches the users. The AI classifies messages in milliseconds, blocking toxic content, flagging spam, and letting clean messages through. You'll build the same production-grade system using Google's Gemini API and Azure Functions. Your API will analyze every message, block the bad ones automatically, and save violations for moderator review, the exact pattern used by platforms at scale. What you'll build in this project, you'll add AI-powered content moderation to your streaming backend using Gemini API and Azure Functions. So why use Gemini for moderation? Google's Gemini offers multimodal understanding and advanced reasoning that outperforms traditional keyword filters. It can detect subtle forms of toxicity like sarcasm, hate speech disguised as humor, and harmful stereotypes, the nuances that simple filters miss. Platforms like Stream, used by Match Group and Midjourney, report 90% less circumvention and 80% fewer fraudulent messages with AI moderation. So that's manual review. Simply can't achieve this at scale. You'll learn how to design prompts that make AI classify content reliably, handle structured API responses, and build the human-in-the-loop review pattern used by production systems. You can use the Ask feature here to check if this project is right for you. You can send that off if you want. Cool. So how you'll build it. First, you'll set up the Gemini API and design prompts for content classification. Then you'll integrate the AI into your existing Azure Functions message endpoint so that every message gets checked before it's saved to the Cosmos DB. So this setup here, so you've got a user sending a message, Azure function goes through Gemini AI, and then it can get tacked into the violations space for the human to review, or for just to group it in a separate spot in the database. So the human review element we'll be working on at the end of the secret mission so there's a get and a patch. So you've got API/violations going to the Azure function, and that goes to the violations DB, or part of the DB, and you've got a patch, which is an approve or reject. So yes or no, effectively, is this a violation or not? Is this like a toxic message sort of thing? Yeah, and you've got this giving feedback, improving the AI. We also look at like confidence scores as well. That's part of the feedback bit. So by the end of this project, you'll have a Gemini API integration for real-time content analysis, moderation logic that classifies messages as toxic, spam, harassment, or clean, violations tracking in Cosmos DB that stores flagged messages for review, secret mission, which is a moderator dashboard API to review and act on flagged content. So a prerequisite for this is this project builds on the previous build of streaming backend on Azure. So you'll need to do that or set up an existing function app with a message endpoint and a Cosmos DB connection. If you haven't completed it, you can start there first. There is also, we'll do the quiz at the end. I'll come back to this too. This here, which is quite comprehensive, is if you need to catch up for the entire thing, there's steps to go all the way from the very start. Like creating an Azure account. Then if you've done part 1 of the series, but not set up the Cosmos DB, which is the secret mission, then you can go through here and do that. It's not awfully complicated, it does take a little bit of time though. And if you have done both, like I have in this so far, in the series, then you can go down this tab here. But what we'll do is we'll go back up and answer this validation first. Cool. So what are we doing in this project? In this project, I'm going to set up a moderation element to my streaming backend I built on Azure, hosted on Azure. This will help me learn how to integrate AI into my Azure workflow. We could say into Azure projects. I'm interested in this because because at scale it becomes impossible to monitor all messages by hand. Cool. So we're going to connect your app to Gemini AI. Every message your users send is about to get screened by the same AI technology that powers Google's content safety systems. You'll grab an API key from Google AI Studio and wire up Gemini to analyze messages in real time. So first, let's make sure you have everything from part 1. As I spoke about before, you can definitely go down these tabs here if you have completed up to different points in part 1 of the series, or none of it. But I have completed all of it, so I'm going to go down this one. So by this point, you should have an Azure Function app deployed and running, a Cosmos DB account with a messages container, and a working post / message endpoint. So if all this is in place, we're going to continue on to the next section. So in this step, get ready to create a Gemini API key. Add the API key to your Azure function. Understand prompt engineering for content moderation. What are we doing in this step? In this step, I'm going to create an API key to add to my Azure function. using Google AI Studio. This is important because to manually go through this process at scale is impossible. In this step, I'm going to create an API key to add to my Azure function by using Google AI Studio. This is important because to manually go through this process at scale is impossible. It's important because I want to use AI in this to process information or messages instead of manually going through this process at scale, as this is impossible. Cool. Okay, I'm going to get our API key. So I'll head to this link over here. Didn't even know Google Chrome could do that. Cool, split screen. So I go to the dashboard and I see immediately the dashboard page opposed to seeing a get started button. So if you go to that link and you don't see any dashboard, you won't be logged in or won't have an account, or however, the setup steps here for this. So definitely feel free to follow those if you're in that position. So in the left sidebar, we can select Get API Key. Click Create API Key. It's another project, I won't use that one just yet. I can stick on this one for now because I've already created it. And then we can copy the key there, or click on it, and then copy it from here. So what is an API key? An API key is a unique identifier that authenticates your request to a service. Think of it like a password that tells Google this request is coming from an authorized user. When you call the Gemini API, you include this key so Google knows who's making the request and can track usage. Google's free tier offers 1,500 requests per day. That's plenty for this. If someone uses your key, it counts to that's part of the 1,500. So you definitely don't want to share that. Yeah, so definitely keep your API key secure. So we'll take a screenshot of this. How did you create your Gemini API key? I created my API key by going to the Google AI Studio and first creating a project, then creating an API key inside of that project. An API key is used to authenticate a user for a specific service. In our case, Gemini AI. I created my API key by going to the Google AI Studio and first Studio. First I created a project, then an API key inside of the project. An API key is used to authenticate a user for a specific service, which in our case was the Gemini AI. Cool. So we're going to add the API key to the Azure app. Your function app needs the Gemini API key to call the moderation service. We'll store it securely in application settings inside of Azure. Cool. So we can go to the Azure portal. I don't use this account. I use a different one over here. Actually split screen this now. Cool. So we'll navigate to your streaming backend function app. So I'll just, you can, any way to get here, but search function app up there. I will select my function app. Then we can go to settings, environment variables here. We'll select add. We can put that tag there, and then we can, actually can't remember if I copied the API key or not. Yeah, I did. Then we can click apply. Cool, so we can see that it's actually saved there, which is really good. Yeah, for sure. So now we can move on to the next step. Setting saved successfully. Sure, looks like it. If you're getting an error, there's some steps here, and if none of that works, then you can use the ask feature or reach out to the community. Can I get rid of this? There you go. Why use application settings instead of hard coding? Storing API keys in application settings keeps them secure and separate from your code. This means you can share your code on GitHub or to other people without exposing secrets, and you can easily rotate keys without redeploying. Azure encrypts the settings at rest and only exposes them to your running function as environment variables. Cool, so we continue to understand how moderation prompts can be designed. Understand content moderation prompts. Before we write code, let's understand how to design prompts for AI classification tasks. For content moderation, you want AI to analyze the message content, classify it into categories: toxic, spam, harassment, clean, return a structured response you can pass. So passing is the act of, and it's quite a common thing with getting a response from an LLM, large language model, to have to pass the output. I'd say a very large majority of the time you'll be passing the output. So extracting information from something which you're interested in. So if I, gave someone a JSON file with a bunch of IDs in it, say, then you had to go and pull out those IDs, but they were in some part of a JSON file that's it's tricky to access, then you would have to pass the output of the JSON file I gave you to extract what you actually want. And so we have to do that as well for this. So here's the prompt strategy we'll use. You are a content moderator for a live streaming chat platform. Analyze the following message and classify it. Respond only with a JSON object in this format. So you've got as allowed, category, confidence, so how likely it thinks it is to um, to be right, and then a reason. Why prompt this way? Role assignment, you are a content moderator, gives the AI context about what kind of judgment to make. Analyze and classify, tells exactly what to do. Respond with only what we've told it to. That's cool. So the JSON format with specific values is allowed, category, etc. Makes it easy to parse programmatically. Without the structure, the AI might return free-form text that's harder to act on. Yeah, definitely a lot easier to parse JSON than free-form text or plain text. What do the response fields mean is allowed. I mean, I think that's relatively obvious, but it's a yes or a no if it's good to go or not, clean or not. Category, classification label for analytics and moderator review. How sure the AI is. So, yeah, could use it for borderline cases if you wanted to only say act on something when it was 90% confident in its decision, then you'd set the threshold to 0.9. And then a reason, like something that a moderator can look at. It's really useful towards the end of this project in our secret mission, and act on that, decide whether they think that's a good reason or not. Cool. So this structured approach makes it easy to parse the AI's response. Cool. Just take a screenshot of this. How do you configure the API key in Azure? I added the API key to Azure by navigating to my Functions app and application settings are used because it keeps our API key away from other people. Meaning a secure API key. How did you configure the API key in Azure? I added the API key to Azure by navigating to the Functions app. Save for this project. And adding an environment variable. Application settings are used because it keeps our API key away from other people, meaning a secure API key. Cool. Yeah, we can see here that it is in the right space, so that's good. Pass the checkpoint. Add AI moderation to your API. Here's where the magic happens. You're about to transform your basic message endpoint into a real-time content filter. Every message will pass through Gemini for classification before it touches your database. So in this step, get ready to create a violations container in Cosmos DB, add Gemini API integration to your function, and modify the post message endpoint to check messages before saving using that function, API. In this step, I'm going to create a new container in my Cosmos DB to store chat message violations by navigating to, or you could say, a Gemini integration to my function so that the post / message endpoint can get access to, can check the messages before saving. This is important because we do not want to save violation messages to our main DB. Cool. So what are we doing in this step? In this step, I'm going to create a new violation or a new container in my Cosmos DB where I can store chat violations. Then I will add Gemini API integration to my function so that the post/message endpoint can check the messages before saving. This is important because we do not want to save the violations into the main DB. Create violations container. Let's first create a separate container to store triggered messages for review. So we'll go to the Azure portal and search for Cosmos DB and then create your account. And select your account, sorry, not create your account. This is what we created in the first part of the series. I'm going to select Data Explorer here. Take a second to load. We can see our current database here. So we'll select New Container. We're going to use existing and then enter streaming DB. That's the name of our database there. And then we can do a container ID violations and a partition key of /stream ID. Cool, so we can see that new container has been created. Nothing in it at the moment. That makes sense. Haven't uploaded anything to it. Endpoints don't even exist for it yet, although sorry, it hasn't been updated to exist from the code base's perspective. So we should see a violation container appear under your database in the Data Explorer tree. We do. And if you're getting an error, then definitely try these, or you can use the ask feature and then go to the next work community. So why create a separate violations container? Separating violations from regular messages serves two purposes. Security, flag messages or flag content may be inappropriate. Keeping it separate prevents accidental exposure to regular users. 2. Review workflow. Moderators can query just the violations container to review flagged messages without sifting through millions of clean messages. And the stream ID partition key matches your messages container, making it easy to correlate violations with their source stream. Sounds good. Let's run to the local version of this project 1 second. Cool, scroll me out of the way. So why do we need a separate violations container? I created the violations container by capitals into the Data Explorer inside of my Azure Cosmos DB. It's separate from messages because it allows me to moderate just what AI has confidently reasoned to be unfriendly or to be filtered. Why do we need a separate violations container? I created a violations container by moving into the Data Explorer inside of my Azure Cosmos DB. It's separate from messages because it allows me to moderate just what AI has confidently reason to be filtered. Cool. So now we're going to add the Gemini integration logic. Now let's create the moderation logic. Open your streaming backend project and your code editor. We're going to be using Cursor. Now we're going to create the moderation module. So create a new file named moderation in your app directory and send this prompt to Cursor. Cool. So I'll just open up Cursor and then head back to my streaming backend project or folder that I created in the previous project. Just wait for that to open. Cool. Okay, I'll just bring that up on the right here. And we'll just send off this first prompt here. So what's happening in this prompt? This prompt asks Cursor to create a moderation module that connects to the Gemini API, sends each message to Gemini to classify with a classification prompt, passes the JSON, returns a structured result, and then uses a fail open so Gemini outage doesn't break anything and break your entire chat. So yeah, well, it explains what fail open there is. If AI moderation fails, API down, passing error, messages get through rather than being blocked. This prevents a Gemini outage from blocking all chat. Cool. So Cursor will analyze your prompt and create a moderation.py file. Click accept changes if it brings anything up. Cursor might respond with something similar to, it's going to create a moderation.py with a check message function, set up Gemini API integration with proper request formatting, add a fail open pattern, so it returns as allowed true if API fails. Cool. Update the post/message endpoint. Now modify your existing message endpoint to check messages before saving them. Open your main function like function file, so functions app, and then send this prompt to Cursor. What's happening in this prompt? This prompt asks Cursor to add moderation to your existing endpoint. So import the check message function you just created in the previous in our moderation.py. We can zoom out and read this. So we've got that prompt, which is going to go, yeah, verify everything's correct. Oh no, this isn't a prompt. Lol. Sorry, that's a header string. I was wondering why it was so high up in the function. This is the prompt. Yeah, so it analyzes and classifies what it is in a certain JSON format. Cool. And then call it before saving any changes. Any messages to the database. If blocked, save to violations container. If allowed, save to the main container. And yeah, that's if you get the 200 response. And then keep all your existing database code intact is another note that happens from this. So why return 403 on blocked messages? HTTP, so 200 is like a colon success, 500 is like a page error, and then 403 it means forbidden. There's actually a few, I could talk about this for a while, but there's a few of these like error codes that are kind of just left that were, people thought were going to be implemented for something a very long time ago. And one of them, I think it's like 401 or something like that, is used, a company called Coinbase have used it recently for because it was written for payments. It was what it was written for in the original documentation for all these errors. And Coinbase have recently set up that for an API that can do crypto payments with. Anyway, interesting. But that's what the forbidden tag is. Is this one for? I think it's 401 or something similar for like API payments. But 403 is forbidden, and that indicates the server understood the request but refuses to authorize it. This is a semantically correct for moderation. Semantically correct for moderation. The user's request was valid, but the content was not allowed. The response body includes a category and a reason, so clients can show helpful feedback, like your message was flagged as spam or inappropriate or really anything. So Cursor's going to modify this file. Cursor might respond with something like the above. This means that it added a moderation import for check messages. That's this function here. The modified post endpoint to call check message before saving if is allowed is false. Saves to the violation container 403, that is, and then if is allowed is true, it saves to the normal database and returns a 200. Cool. So I actually did see it update requirements. It's put requests in here, but there's every chance it doesn't. So if it hasn't, then go and make sure these three are in there and add that. But it has for us this time. So we'll just keep going down here. So why do we need the request library? The request library is Python's most popular HTTP client. We use it to make post requests to the Gemini API. Azure Functions will install this when you deploy. Cool. Screenshot of our moderation code. I think it's pretty funny how I read that out loud a minute ago as a prompt. It's just a doc string. But hey, we'll make mistakes. How does your AI moderation code work? My moderation code works by getting Gemini to class the user's comment as loud, gives category, the reason, then the passed output, or the output is passed, and we decide whether whether we post this comment gets posted, and 2, it's kind of the same thing, which database container this belongs in. This message belongs in. The fail open pattern means if Gemini goes down or we run out credits, our chat doesn't just break. Cool, so moderation code works by getting Gemini to class the user's comment and then pass that output from Gemini. And whether this comment gets posted, let's skip the line. And we decide whether the comment gets posted, and 2, where it gets sent in the database, which is kind of the same thing, but 2 kind of separate actions. And the fail open pattern means if Gemini goes down or we're in no credits, then chat doesn't just stop. Cool, so watch your AI block toxic messages. Moment of truth, you're about to deploy your moderation system and watch it catch toxic content in real time, just like the system's protecting millions of users on platforms like Twitch and Discord. So in the step, get ready to deploy the updated Functions app. test toxic messages, clean messages, and then review flag messages in the violations container. What are we doing in this step? In this step, I'm going to deploy my function to Azure by using the func. I think the full name for it is function. I think it's Azure Function Tools or something like that. The command /func from Azure Function Tools. This is important because it allows me to quickly deploy and test my moderation code. To deploy my function to Azure by using the command /func from and test this moderation. What are we doing in this step? In this step, I'm going to deploy my function to Azure with the /func command from the Azure Function Tools, or from Azure Function Tools, say SDK, I guess, and test this moderation. This is important because it allows me to quickly deploy and test my moderation code. So we're going to deploy to Azure now. Time to deploy your updated code to Azure Functions, to my Azure Functions app. So we're going to open a terminal, and here, a command, or shortcut, sorry. Make sure you're in the streaming backend project folder. Run this command. This can take 30 odd seconds, maybe longer. We'll see this pretty quickly, but then there's a little bit of a, or at least this bit pretty quickly, but there's a bit of a delay for this bit and a bit more. What does this command do? This command packages your Python code, including the new moderation.py file, and uploads it to your Azure Functions app. Azure will install the dependencies from requirements.txt, which added one before, requests with your changes. And yeah, if you have a different app name, then you'll need to update this as an app name, folder name here. Everything's stored and you'll need to update that. But if you're following along with the project so far, we just called it streaming backend, but I called mine. Yeah, I wonder if that'll work. Should do, but cool. Okay, so we should see something like this pretty soon. Cool, so just finished deploying now. Yep, so you should see an output ending with deployment completed successfully. We'll copy this section there. Any of them actually will do fine, just as long as we don't get the API bit there. So we'll just send that in there. And if yours is the same as the what was the placeholder there, that's totally fine as well. So we're going to test with toxic messages now. Let's test the moderation with messages that should be blocked. I'm going to open a new terminal, cursor. Cool. Cool. So we'll go into Windows, and then I'll copy that into here. I click no. I press return twice, and I said no, I've got to wait, and then it'll, yeah, there you go. Okay, this is a good example. We can have a look at this because this was supposed to return as a message that was blocked, but it was allowed, and I ran into this issue when I was putting this project together. We can have a little look as to what exactly is going on here. So if we go to our, if we go to Functions app, for our streaming backend, then we can go to log stream, and then we'll have to send this again. There's two possibilities. One, Gemini just decided that wasn't, sending a 3 right now. Have a look here. 2.5 flash, that seems legit. Didn't think it was sent like good enough, as all like, I don't know, toxic enough, I guess. Or we don't have an API key set. So we can check that out. What it reckons here. So I'll zoom out a little bit so we can see some stuff. So we would see something at the top saying like a problem with the API key. So that's not the issue. Let's try make this. We go to the message here. I don't know. Let's see if we can just get it to trigger, because we can understand whether it's a there you go. Okay, so the in that case, it was the fact that the message wasn't flagged by Gemini with the current prompt set up to be toxic, I guess. Terrible choice. So yeah, that's not an issue with the code. That's just an issue with the what was being sent to it. And you know, this is where you could go into the moderation prompt, not the doc string like I said earlier, and then you could give it some more specific information around what is acceptable and what's not. For instance, you could literally say it's unacceptable for to say terrible choice, and then it would go and detect that. If I sent this again, or if I deployed the code and sent this again, and it would say a 403 rather than what it was giving us before, which was a 200. Cool. So yeah, that's not necessarily a problem with the code. It's just Gemini with this prompt didn't classify what I had before as toxic. This means that moderation is working. The AI correctly identified and blocked the toxic message. What just happened? When you sent that request, your Functions app did the following. First, it received the message via HTTP post, sent it to Gemini with your moderation prompt. Gemini analyzed the content and returned is allowed false, in our case true first, then false. Your code stored the violation in Cosmos DB, returned a 403 with the rejection reason. So all of this happens in typically less than a second, fast enough for real-time chat moderation. So let's test a clean chat message. We kind of did by accidental before. We'll go into Windows and send this one off, and this should return a pass. Cool. So it's flagged that it's okay. So that makes plenty of sense. I'll just resend this so we can get a response to 403 there. I tested moderation by sending both toxic and clean, say, chat messages. The AI responded with 403 for the toxic message and 200 for the clean message. this shows the AI is moderating correctly. Cool. So now we're going to review the violations in the Data Explorer. So if we go back to this, and we go over to Azure Cosmos DB, select that, then go to Data Explorer, and we should be able to see some items in this. There you go. So they'll both be the same one. I'll zoom out so we can see it. Yeah, I think it's the "you're an idiot" one I put before. Both of them will be. Cool. You should see the test violations with the original message, category, confidence score, reason for blocking, and a timestamp. Why store all of this information in metadata, which is this thing on the right. Each violation document captures the full context, message, the actual content for moderator view, review. We'll get into that in secret mission. Category, what type of violation, confidence, how certain the AI was. We can see for this, it was 0.98. User ID / username and a timestamp. So when data enables dashboards, analytics, and appeal workflows, which you'll build. This data enables dashboards and analytics and appeal workflows, which you'll build in the secret mission. Cool. Send a screenshot of this. What metadata is stored for each violation. I reviewed the violations by going to the Explorer section of my database. Each violation includes ID, content, username, category, confidence, and reason and timestamp. This metadata helps when I want to create dashboards, better understand analytics. Cool, so what metadata is stored for each violation? I reviewed the violations by going to the Data Explorer section of my database. Each violation includes ID, content, username, category, confidence, score, reason, and a timestamp. This metadata helps when I want dashboards or better understanding around analytics. Cool, so now we're going to, in the secret mission, we're going to give moderators the power to override AI. So no AI is perfect. Twitch's auto mod lets streamers adjust sensitivity. Discord bots have special appeal forms. YouTube's filters can be overridden by channel owners. Why? Because AI blocks a sarcastic joke or misses a subtle harassment. You've built the AI side, now build the human side. An API that lets moderators review flagged content, overturn false positives, and track what AI is catching. This is the human in a loop pattern used by every major platform. Cool, so we have the Azure Function app, like we've set up here, the toxic spam clean classification of Gemini, and we have Cosmos DB for both violations and messages. Cool, and we're setting up moderation.py inside of that, and you'll see where this diagram goes. There's a few more in this secret mission. So your AI is blocking toxic content, but what about the message that looks toxic but actually was just a sarcastic joke between friends? or the clever spam that gets filtered out. That doesn't get filtered out, sorry. False positive frustrate users, false negatives harm the community. That's why platforms like Twitch, Discord, and Match Group don't deploy AI and walk away. They build dashboards and let humans moderate. Moderated review, override, and improve their system. So in the second mission, get ready to create a get endpoint for list flag violations, add filtering by category, date range, and review status, build a patch endpoint to approve or reject violations, track moderator actions with audit logging. So why every platform needs human oversight, the human in a loop pattern. Twitch's auto mod doesn't just block messages, it lets streamers adjust sensitivity and review borderline cases. YouTube's comments filter can be overwritten. Why? Because AI moderation at scale will make mistakes. Your dashboard API gives moderators the power to catch those mistakes. Create the get violations endpoint. First up, an endpoint that pulls all flagged messages for a moderator review. Think of this as the inbox for your moderation team. Open your streaming backend in Cursor, create a new file called violations.api.py in your app directory, send this prompt to Cursor chat. Before we do that, we'll just quickly fill out this validation here. In the second mission, I'm going to build a get endpoint to list flagged violations, add filtering by category. This needs AI moderation because at such large scale, AI will make mistakes. Cool, we already read over that. And we're just going to send this prompt to Cursor. What's happening in this prompt? This prompt asks Cursor to create a moderator dashboard API that has query parameters so that you can let moderators filter by category. Date cutoff prevents loading years of old data. Dynamic query building, so adds filters only when specified. And then you've got a limit that keeps responses manageable. So this is kind of what we're setting up at the moment, sort of as I spoke about before, this diagram. We're building this moderation.py, but this is, the bit we're sort of up to now. We'll continue to build on this as we go. So we've got a get violations function there for violations. Let's go API.py, which just got created here. So moderator will call that get API function. We'll query with filters, and then we'll be able to get violations and return it back to them, the moderator. So Cursor will generate that. I'm going to add the review action endpoint. So reviewing what we think of this specific violation. So now the power move and endpoint that lets moderators say yes, I got this right, or nope, that was a false positive. In Cursor chat, we'll just send that prompt off. Cursor will add the review violation function to your file, accept changes to apply. Why track false positives? When a moderator marks a violation as rejected, false positive, that's valuable training data. In production, you'd collect these examples to fine-tune a model, adjust AI sensitivity, and build test cases for the moderation system. So we had this sort of top-line pipeline before, and now we're having this review violation function, which lets sort of go duplex two-way path there. You've got a patch and you've got a response for the updated violation. And this goes to here. I can zoom in there. Can I scroll? Here you go. So we're adding review status, reviewed by, reviewed at, to the violations container. So we can keep track of who's doing what. Now we're going to wire up the endpoints. Time to connect your new functions to the HTTP routes that moderators will call. So open that and we'll send this prompt off to cursor. Cursor will update functions app.py. Why use patch instead of put? The REST API design patch is used for partial updates, changing specified fields. So setting this to like true instead of false for whether it's spam or we want to suggest it's a violation. It's a good use of patch rather than put. What is the route syntax ID? The ID in the route is the path parameter. It captures whatever comes after violations in the URL. So a request would set request.route parameters get ID. This lets you build a RESTful endpoint where the resource ID is part of the URL. So this is the full system. Once that has finished now, I'll just deploy this and I'll speak about this thing. So we have the moderator, we have the end user. Obviously they don't see functions underscore app.py, but they are in many ways interacting with it by sending a message to the chat. We've got processing message, we're getting violations, reviewing the violations, and there's already an existing health check, which isn't really part of all of the stuff we've just implemented, but still a function between there and the database. And the moderator sort of has control over the processing message, and then these two are the ones who just added. Well, actually, they don't have control over processing message immediately. They have control over these two, getting violations, so they can call that and reviewing a violation. We'll just wait for that to deploy, and then after that, we can get some violations using the that endpoint there, and then we will, from that, go and we can patch some violations based on our own sort of manual overview. Cool, so that's just finished deploying now. We can, what do we get up to? Get all pending violations from the past 7 days. So we can send that off. Take a second. There you go, we get the violation, category, confidence score, etc. And if you had it was an empty list or you got an error, then you can go down those tabs there. But we got a list, so we'll keep going down this way. Now let's try filtering by category. So I'm just going to clear this, make this a little bigger so we can see what's going on. Cool. Looks good. Okay, we can send the, that's category again. So you could change this to, I think it's called clean, I'm not actually sure, to sort by only clean messages, but in that case it was just toxic ones. I created a get endpoint by specifying, if you look into what the get endpoint does. Yeah, so it's going to retrieve messages from there. Okay, cool. This endpoint. The query parameters let moderators sort by category. Filter, e.g. sort by category. How does your get violations endpoint work? I created a get endpoint. This endpoint retrieves messages from the database. So a moderator can review them. The query parameters let moderators filter, so they could just sort by a category. Cool. So now we're going to test the review endpoint. So we'll clear this again. Use that one. Should see a list of IDs here, or 2 in this case, and we'll just copy one of these, put it into this so we can then review this. So hypothetically, we're saying, okay, we've actually looked at this, and we want, we've got our moderator ID and whatnot correctly identified as toxic, and we're saying, okay, this is, yeah, we agree with the AI's take on this. So we paste that in, then it won't change much, but we could reject, and then that would do the opposite. It would say, hey, look, the AI didn't make the right decision. So we'll keep that open. But yeah, so if you had some errors here and validations not being found or other errors, then you can go down those, but we saw it worked correctly, so we're just going to keep going down this way. Feel free to check violations, violation container and Cosmos DB to see the updated document with review fields. That's the one on Azure. So what makes this an audit trail? We spoke about that at the start. The review actions add, reviewed by, reviewed at, and review notes to the document. This creates an audit trail. You can always see who reviewed a violation, when and why. In production systems, this is essential for accountability. Like, you know, we put in here mod 123. Obviously, that's a pretty placeholder ID, it's just a placeholder ID. But, you know, that would ideally be, there'd be some sort of auth, and then you could only do something like this in an interface with a dashboard if you were logged in, and then that was in the ID, and you could hold people accountable for moderating certain things, that sort of thing. Cool, so we'll send a screenshot of our review action. How does the human in the loop pattern work? Test the review endpoint by reviewing a specific violation via ID. The audit trail includes we've got moderator ID and notes. This helps moderators hold each other accountable. How does a human in a loop pattern work? I tested the review endpoint by reviewing a specific violation via ID. The audit trail includes moderator ID and notes. This helps moderators hold each other accountable. Taking it further, in a real production system, you might also add user appeals, severity levels, user reputation, and you could convert all of this into a dashboard like I spoke about before. Cool, so you just built a complete content moderation loop. Violations are caught automatically and humans review edge cases, and feedback improves the system. How good. Okay, so clean up resources and before you go section. I'm going to keep this open because I'm going to go and do the other 2 projects in the series. Feel free to remove the API key, or if you want to delete everything, there's steps here. But yeah, we'll keep everything running for us because we're going to go and do this a bit later. We're going to do the next project a bit later. The key tools I used include Azure and Cursor. Key concepts include, I learnt include, let's see, moderation, prompt engineering, APIs, cool. How long did this project take you to complete? Hour and 10 minutes, so 1.25 hours. The most challenging part was getting the AI to not be too sensitive to toxic comments. Actually, it was the other way around. It was getting the AI to be more sensitive to toxic comments. It was rewarding to see the review workflow in action. Thanks for doing this project. Why did you do this project today? Did this project meet your goals? I did this project to learn how to implement AI with Azure. Another skill I want to learn is we could say setting up Azure both. Could be cool. Cool, so you just built a production grade AI moderation system. It's the same system that every big chat moderation, or every big platform that has to have chat moderation uses. What you learned, how to integrate Gemini AI for real-time content classification, Azure Functions for serverless API development, Cosmos DB for storing messages, API key management, fail open pattern, and designing prompts for AI classification. Tasks, AI classification tasks. Where should a Gemini API key be stored? Application setting sounds correct to me. Primary reason for creating a separate violations container to store only metadata to improve query performance, to prevent accidental exposure. That's right to me. What's the purpose of the fail open approach? To automatically retry, to queue messages, to allow messages to pass through the AI if moderation services unavailable. That's right to me. Which HTTP status code is returned by the slash message endpoint when a message is blocked? It is the 403 forbidden. Which platform do you obtain the Gemini API key from? AI Studio. Cool. Such a cool graphic. Yeah, that's this project. I think it's super cool. I think it's another project in the Azure series. Super excited to get this one out. I really hope all you guys enjoyed it. Thanks for following along if so. And we'll see you for the next project in the 21 and 21, another 2 more Azure projects. Alright, see ya.